All right, so looking at our last example here, we have x, y double prime minus y prime plus 4x cubed y is equal to 0, where y1 is equal to cosine of x squared. So our first thing that we want to do here is get our differential equation in the format where the y double prime only has a coefficient of 1. So we want to divide everything by x. So we have 1 over x here, and then plus 4x squared y is equal to 0. And so now, in order to find our y2, we need to find our u, which is equal to the integral of e to the, let me double check here, negative integral of a. And then we divide that quantity by our y1 squared. So subbing in what we know, our a is whatever is attached to y prime. So here we have u is equal to the integral of e to the negative 1 over x dx times cosine squared of x squared. And so to simplify our numerator here, if we have these two negatives, those are going to cancel out, and then the integral of 1 over x is going to be the natural log. So here we have the integral of e to the natural log of x dx over cosine squared of x squared. And so these e and the natural log are going to cancel out, and we're just left with x dx over cosine squared x squared. And then this this cosine here in the denominator, I'm going to rewrite this as secant. So since this is 1 over cosine, I can rewrite this as the integral of x secant squared of x squared dx. And this is actually a trig identity here. So this is called the half angle rule, as well as the secant here. So this is going to give us 1/2 tan of x squared plus c. And so now, this is our u, so we know that from what we listed here, y2 is equal to y1 times u, so our y2 is going to be equal to 1/2 tan x squared times, sorry, I apologize, we don't need this c just yet. That's going to come into play in a second. 1/2 tan x times cosine x squared, and then since tan is actually sine over cosine, this cosine is going to cancel out with this cosine, and we're just left with 1/2 sine of x squared. And so our format for our general solution is going to be c1 y1 plus c2 y2. So this is going to give us c1 cosine of x squared plus 1/2 c2 sine of x squared. And then that is our solution. So this was our order of reduction example here. All right, so that was our last example. So again, this was just order of reduction. So you should be able to, again, identify when to use Bessel's, Legendre, and Laguerre's equation, as well as you need to know and how to implement your PDEs for Leapfrog and for Word Euler. So we're not going to do an example of that, but again, make sure that you know those formulas and you are able to implement those. All right, have a great rest of your day, everyone.